Good afternoon, students. Today I am discussing about the comparison of densities of solid, liquid and gases. We already know about the density, how we can calculate the density of any substances, and also we already know about the relative density of any substances. We know that the relative density is the comparison of the densities between the density of the substance, comparison of the densities between the substance and the density of the water kept at 4 degrees centigrade, and it have only the numerical value and no units and as well as dimensions. Now when we compare the density of solid with liquid and gases, we get that for solids have a definite shape, distinct boundaries and fixed volumes. So for solid it have a high density because the intermolecular force of attraction between the solid molecules are very much greater, and this intermolecular space between the molecules of solid material are very less. So if we draw the diagram of a intermolecular things, it looks like that. If we draw a diagram like that, it looks like that. If we take a solid material and inside if we draw the molecules, it are very closely packed. Every molecules are very closely packed inside the solid matter. So it have less intermolecular space, so it cannot move here and there, and it only vibrate about their fixed position like that. In that way it only can vibrate about their fixed position. Every molecule inside the solid matter cannot move from here to another place, and as they have very small space between itself means if every molecule have very small space between them, so the mass of the solid, if we consider the mass of the solid is m, so as there have very small space between them, so they are very closely packed and the volume will be less, v will be less for solid. So we know that density rho equal to mass by volume. So as volume will be less for the solid, so we can say that density will be very high for solid. So we can say that solid have a high density because the density of a solid may be defined as the mass occupied by the solid per unit volume. If we take this volume as 1, that means unit volume, so we can say that rho equal to m for v equal to 1. So for unit volume, mass of the substance is called density of that substance for solid, because we can measure the volume of solid. Now since the constituent particle in the solids are very closely packed, so the density will be maximum in solid state of the substance, in the solid state of the substance. Now thus we can say more closer the constituent particle, that means which constituent particle are closely packed, they have less space between the intermolecules of the constituent matter, then greater will be the density. Everyone understand? Okay. Now for liquid, in a liquid particles they are loosely packed if we compare with the solid. So the space between the particles are slightly more than that in solid. If we draw the diagram of the particles of the particles or molecules of liquid, that is for solid. Now if we draw the diagram of the liquid, it looks like that. The molecule inside the liquid are loosely packed about the solid. Like that. So the intermolecular space between the liquid is more than the solid, and intermolecular force of attraction between the molecules are less with the, if we compare with the solid. So as intermolecular space is greater, so it have, for the same number of molecules, if we take the same number of molecules for liquid, they have greater volumes to arrange it. So for the same mass of the substance, as density equal to mass by volume, so for the same mass of the substance, same number of particle of the substance, liquid have greater volume than solid. So as liquid have greater volume is greater than solid, so density will be less than solid. So we can say that liquid have moderate to high densities because its particles are close together but less than solid. Now there have some exception also, for like water and ice. Now ice have very closely packed, but also when we kept the water, this ice melts and makes its water. If ice have the molecule of the ice are very closely packed, you already know, and the density are very high. But if we take the water and kept at 0 to 4 degrees centigrade, within 0 to 4 degrees centigrade, the molecules are more closely packed than ice in the water. So the density of water is greater than the ice. There is an exception case. But naturally, liquid have lesser density than solid. Clear? So comparing this solid and liquid, we can say that the liquid have moderate to high densities. Like mercury have very high density, but it is a liquid. So we can say that liquid have moderate to high density because its particles are close together but less than solid. Now gases have neither a fixed shape nor a fixed volume. Hence we can say that they do not have a fixed boundaries also. So we cannot measure the fixed volume of a gases. But if we enclosed some gases inside a container, and we can measure the volume of the gases, and we also can measure the enclosed mass of the gases enclosed in a container. When we measure it, we know that the intermolecular space between the gas molecule are very low. Intermolecular space is very high, because gaseous molecules are moves here and there, and they have a random motion because they have very high intermolecular space. So if we draw the molecular structure of the gases, it looks like this. They are very high intermolecular space, and they neither have any intermolecular attraction. They have very less amount of intermolecular force of attraction between itself. So we can say it is negligible amount of force of attraction between itself. So for taking same number of molecules like solid, we can make very large volume of the gas container. So as volume increases for gases, so we can say that density of the gases equal to mass by volume. As volume increases, so density will be decreases for gas molecule or gaseous matter. So we can say that the gas particles are very loosely packed inside it, and that's why it have a lesser density than solid and liquid also. Clear? So if we draw a graph like that, the density in the y-axis, and for solid, liquid and gases, if we take, the density of solid is very much high like that for a specific molecule. When it becomes the liquid, the density will be less. It becomes the liquid, density will be less. After that, when we get gases, the density will be very less for gaseous molecule like that. Density of the liquid gases is very less, density of liquid is moderate, and density of solid is very high. Clear to you? Thank you for this class.